This video is a summary video of the first module inside module number 1, the ATA00, call it, the Aircraft General Introduction. Remember, you do need to read the accompanying notes to get the full nitty-gritty. Called NG series, or Next Generation series, is a derivative of the 737 family, a development of the old-fashioned classic. Covering the 6, 7, 8 and 900 variants. It was launched in 1997 and is for short and medium range flights, and with a seating capacity of between 108 and 215 passengers. Give you a size comparison of the aircraft in a series. On the NG series, they do follow in nice logical sequence, unlike the classic. So the 600 being the shortest, and the 900 series being the longest. So they range in size from the 600 is just over 102 feet long, up to the 900 series, which is just over 138 feet long. The picture on the right, it just is in the middle there, it's showing you the 700 series. So overall length, measured from the tip of the nose to the extremity of the horizontal stab, just over 110 feet. And like all of them, they all stand from the ground measured to the top of the vertical stab at just over 41 feet. Total wingspan from tip to tip, 112 feet and 7 inches. This is the fuselage dimensions and body stations. All of these station references, whatever we're measuring, are always given in inches. And they have basically 3 main areas: the body station line, the body buttock line, and the water line. There are others for the wings and the pylons, etc., but we won't go into those at the moment. So we've got the body station line, the body buttock line, and the water line. The body station line is a horizontal dimension, and it starts at station 0. Now, station 0 is a point in front of the tip of the nose. It's basically a point on the jig in the factory, but it's in front of the nose. So the first bit of aircraft that we hit in terms of the body station is the tip of the nose, which is at station 130. And then all the station numbers after that go working backwards, increase in number, given in inches. The body buttock line is a lateral dimension, and you measure the body buttock line from either the left or right of the aircraft center line. So if you took a fuselage that we can see at the bottom of the picture there, that circle, cut it in half vertically. Then we have the left side and the right side. Obviously, the left and right referencing in the traditional way that we reference left and right, i.e. standing in the aircraft looking forward, and then from left and right from there. And again, if we cut with the aircraft center line cut in half, that's station 0, and then we've got left or right, and then the number giving you so many inches from that station 0. The water line is a height dimension, and you measure the water line from a station 0, which is a horizontal reference plane below the aircraft. So once again, it's the jig in the factory, the aircraft's built on a jig, so it'll be a reference point on the actual jig. So the first bit of aircraft that it hits, if you like, the first bit of the fuselage at the bottom will be waterline 148.5. So that's 148 inches from the reference point. And then it goes from there, counting it upwards to the top of the fuselage being waterline 306.5. NGs are powered by 2 CFM56-7B engines. Obviously, we'll look in detail at the power plant system when we do module 4. So this is just an overview, okay, give you a rough idea of what's going on. So we have 2 CFM56-7B engines with an EEC controller. General common sense, really, the safety zones when the engines are running. So avoid the intakes when the engines are running. I think people do tend to get a bit complacent, but there have been several occasions where people have been sucked into a running engine. They are very low to the ground, and they're very big fans. So avoid the intake area when they're running. You can see the shaded area where to avoid. If you do need to approach an engine when it's running, when you're doing leak checks, etc., there is two safe entry corridors where you avoid the intake and you avoid the exhaust. So basically it's a plane, 45-degree plane from the about 5 feet behind the intake on either side of the aircraft or engine. Flight control surfaces, so we have primary and secondary flight controls. The primary flight controls comprise of the ailerons, there's one on each wing, 2 elevators and the rudder. We've also got spoiler panels on the wings. Those of you who are converting from Classic to NG, you'll notice there's 2 extra spoiler panels, and also they are numbered differently. We'll look at that on the next slide. Secondary flight controls comprise of the leading edge flaps, 2 per wing, leading edge slats, 8 per wing. Again, those of you are converted from the Classic to the NG, so you'll notice now we've got 2 extra slat panels. Trailing edge flaps are 4. We've got a total of 12 spoiler panels, 6 per side, so that's there's 10 on the Classic, those of you converting, and that comprises of ground and flight spoilers, of course, and the spoilers are numbered differently for those of you converting, and for those of you who aren't, this is it. So spoilers are identified 1 through to 12, running from left to right. So on the left wing, the far outboard spoiler panel is spoiler panel number 1, and they just count sequentially inboard and then carry on, starting with spoiler panel number 7. This is the first panel on the right hand wing all the way through to 12, which is the far outboard panel on the right hand wing. We've also got movable horizontal stab, of course, and leading edge slats, leading edge flaps. Main access doors, we've got the forward and aft entry doors at the front, with forward and aft galley service doors, well, front and rear on the right hand and left hand side. Emergency overwing exits. Now note, actually, it's showing in the picture there 2, 1 per side. On the 800 and 900 series, there's an additional 1 exit per side. And the other difference, those of you who are converting from the Classic to the NG, the other difference to note is that these overwing exits, they hinge at the top and open outwards. So that can catch you out if you're not used to it. We've got cargo doors forward and aft on the right hand side, lower part of the fuselage. There's various interior doors, the crew door and the lavatory doors, of course, and then we've got various miscellaneous access doors to get access to the avionics compartment, the APU, and various servicing panels. The biggest takeaway when opening the main entry doors, the biggest thing that's going to cause you either embarrassment or even injury is if you try and open the door when it's armed. So the first thing is to make sure it's not armed. If you're opening it from the outside, there's a little placard or a pennant that comes across the little viewing window. If it's clear, the door is safe and you can open it. Don't try and open the door if the escape slide is armed. Apart from that, you need to go out to the aircraft to practice doing it. Open the door from the inside, but once again, you need to disarm the slide first before you try and open it. Once you disarm the slide, you can open the door safely, and the door kind of swings in towards you, swivels round kind of 180 degrees and goes, opens up, moving forward of the entrance hole. door from the inside. Unlatch the door with a control handle after having disarmed the slide, and turn the handle towards the open direction. That puts the door in the cot position. You push the door through the door frame until it's fully open, and use the assist handle to do this so you don't fall out. A hinge lock mechanism in the upper hinge keeps the door held in the fully open position once it's fully open. When you close the door, you first have to release that hinge lock. The release mechanism is yellow, so it's easy to see. Operate the latch release mechanism to unlock the hinge. This lets you swing the door back into the door frame. You pull the door into the cot position, turn the control handle to the closed position, and there you are, you're good to go. Then, obviously, if you're departing, the crew would then arm the doors once they get the instructions. Inside the flight deck now, we're looking at the flight deck now, and all the panels are identified with a P number, P1, P2, and so on. They will become second nature once you get, by the end of the modules, actually, under the end of the 5 modules, you will know these off by heart. So if I said to you, if you said to me, where's the so-and-so and so-and-so control, I'll say it's on the P5 panel, you'll know exactly where it is, okay? So all the panels are identified as P1, or with a P number, P1, and so on. P1 is a captain's instrument panel. P2 is a center instrument panel right in the center there. P5 is the overhead panel and is actually made up of kind of a forward bit and an aft bit. The forward panel is where most of all the systems controls are. So you've got 2 P5 panels, an aft one and a forward one. P7 is a Glareshield panel, it's above the instrument panel. P9 is the forward electrical panel. Then we have our control stand, where the throttles are. And the P8 panel is the aft electronic panel. And we'll take a look at what's all on each of these panels in a second. Showing you in a bit more detail the main instrument panels, comprising of what's shown here is the P1 panel, the pilot side, and the P3 panel, the first officer's side. So the NG is a glass cockpit. So you have your display units there, the outboard and inboard display for the pilot and co-pilot respectively. We've also got on the instrument panels a couple of clocks, one each side, 4 display units on those 2 panels, a display select panel which we'll go through when we get into indicator and recording, which is later on in this module, master dim and test switch, yaw damper indicator, brake pressure indicator, GPWS or enhanced GPWS control panel, some various lighting controls, and there's a little air outlet for the air conditioning. The Glareshield panel, we've got master caution annunciators, left and right hand side, system caution annunciators, left and right hand side. There's a mode control panel for the autopilot. There's an EFIS control panel to manipulate the screens and control various functions on the EFIS, the electronic flight instrumentation, and fire warning lights, one each side. Instrument panel, which is the P2 panel on the main instrument panel, the one in the center is the P2 panel, and also shown here is the P9 panel, which is on the forward part of the center pedestal. So on the P2 panel, we've got our standby instruments, engine display control panel, the anti-skid and auto brake switching and lights, flat position indicator, landing gear selector lever and position indicator, and the upper center display unit. 9 panel, we've got the lower center display unit and 2 CDUs, that's controls display units. Again, we'll look at those in detail when we get into those systems, but it's where you sort out your flight management system and various other functions. Going back down the center part, the center pedestal, if we can call it that, we've got our control stand comprising of our thrust levers and thrust reverse levers, the speed brake control lever, the horizontal stab trim wheel and indicator, parking brake lever and indication light, flap selector lever, and the engine start levers. Moving back down the center pedestal, we've got the P8 electronics panel, or the aft electrical panel. So on here we've got various system controls for the weather radar, the fire protection system, TCAS and ATC control panel, VHF radio controls, nav control panels, audio panels, the aileron and rudder trim control panel, some various lighting controls, a printer if you have it, and the ADF system controller. So this is part of the P5 panel. This is the aft P5 panel. So on this panel, you've got the inertial system display unit, engine control panel, the observer's audio control panel, oxygen control panel, landing gear indicator lights. There's a dome light switch, service interphone switch, the IRS mode select unit, and a leading edge devices annunciator panel. It's a forward P5 panel. It's where most of the aircraft systems are controlled from. So on this overhead panel, the P5, we've got APU control switch and indicator panel, fuel control panel, ground power and switching panel, equipment cooling panel, generator drive and standby power panel, the AC and DC meter panel, flight control panel, air conditioning and bleed controls, hydraulic controls, cabin altitude panel, cabin pressure control panel, and engine start panel. Most of all the avionic LRUs, etc., are in the electronic compartment. This is a compartment below the main cabin floor, just aft of the nose wheel well. And on the ground, you can enter this compartment through a door in the lower part or the bottom of the fuselage. It's otherwise known as the E&E compartment. This access door is located just after the nose landing gear. Inside the E&E compartment, there are 5 standard equipment racks identified as E1, 2, 3, 4, and 5. E&E compartment is a pressurized compartment, and it's accessed through a door just behind the nose landing gear bay. And it's a plug type door because it's pressurized. So to open the door, there's a push button trigger release to release the handle, and then you pull the handle down. You turn the handle counterclockwise to disengage the latch pins. When the latch pins are free, you can then push the door upward and slightly to the right to the first detent, and then push the door to the right to the fully open detent. When the door is fully open, the roller tracks can be folded to give you better access to the equipment racks. A spring catch on the end of each roller track holds a track in the folded or unfolded position. To close the door then, before you close it, release the spring catch and extend the roller tracks and make sure the door frame area is completely clear. Pull the door out of the fully open detent, then retain it as gravity causes it to slide down the tracks. When the door reaches a lower detent, you can release it. Turn the handle counterclockwise to retract the latch pins. If you don't do this, the door will not seat in the door frame properly. Pull the handle to the left, and the door will come out of the partially open detent. Then it slides right down into the door frame. You can then turn the handle clockwise to latch the door, and then push the door handle back into its recess. Inside the E&E compartment, looking forward, you'll see the E1 rack. On the E1 rack, you've got various boxes, including the auto throttle, the autopilot, comms equipment, navigation equipment, and the flight control computers. Looking rearwards, you'll see equipment racks 2, 3, and 4. And on here you got, again, a whole bunch of boxes, including the window heat, some more comms, electrical power, distribution boxes, the common display system computers, the flight control system computers, and fire detection and APU controller. To the right, you've got the E5 rack. On here, you've got the Air-Day inertial reference system and flight management computers. So a lot of the LRUs are controlled by internal digital computers, and a lot of them are kind of off-the-shelf computers that need to be personalized so that it knows it's installed to a 737, either 600 series, 700 series, 800 series, etc. So a lot of that personalization is done through pin programming. So we have something called the program switch module, and they just are pins, and we can see some dip switches there where we can set up in accordance with the AMM. It will give you the position of the dip switches if you need to configure it, so that all the modules get personalized to that particular airframe. This is a fairly digital aeroplane, so a lot of LRUs require us to upload software, and we can even download information from the LRUs. So what we have is an airborne data loader. Now the picture is showing you a floppy disk drive. They're obsolete. It will be a USB kind of drive now. But the various, and there's also a data load switch, so we can select what LRU we're kind of uploading or downloading. So the following LRUs have got loadable software, so the flight management computers, the display electronics unit, the ACARs, the flight data acquisition unit, the aircraft conditioning monitoring system, ACMS, the air show, the EEC for the engine, and the APU engine controller. However, as a caveat to that, for the EEC and the APU control, we'll need a special data loader for that. But everything else, you can use the onboard aircraft data loader.